Hello everyone. Today we are going to discuss about the bipolar junction transistor. Myself, Dr.I.Baranilingesan, Assistant Professor in the Department of EEE, KPR Institute of Engineering Technology, Coimbatore. Overview of bipolar junction transistor. In this tutorial, we are going to discuss about what is transistor, types of transistor, structure of bipolar junction transistor, operation of LPN and PNPN transistor, and various configuration of common emitter, common collector, and common base configuration. What is transistor? A transistor device like a diode cannot amplify the signal, therefore its applications are very limited. The next logical step in the development of the semiconductor devices after a diode is called transistor. The term transistor means trans and resistor. Transfer of input current from a low resistance circuit to the high resistance circuit, that is called the transistor. Let us discuss type of transistor. Transistors are classified in two categories. Here is that one is the bipolar junction transistor and field effect transistor. Again, the bipolar junction transistor classified into two categories. One is the NPN transistor, another one is the PNPN transistor. Now coming to the point of field effect transistor. The field effect transistor classified into two categories. One is called junction FET or junction field effect transistor, and another one is the metal access semiconductor field effect transistor. In junction field effect transistor, it has a one mode called depletion mode. In this depletion mode, we have a N-channel junction field effect transistor and p-channel junction field effect transistor. Where in case of metal oxide semiconductor field effect transistor, simply we can say it as the MOSFET, classified into two category. One is the depletion mode, another one is the enhancement mode. In each mode, depletion mode as well as the enhanced mode, there will be a p-channel and the n-channel. So this is the types of transistor and the classification of the transistor. The bipolar junction transistor was developed by the doctors Copley with Bell Laboratories in the year of 1947. This was invented for the first application telephone switching circuits. Uh, After this, as like that of PN junction diode, it has a three terminal, where in case of PN junction diode has a two terminal, and PN junction diode has a one layer, it has a three layers, it has a two junction devices. The current conduction bipolar junction transistor is because of both the charge carriers, electrons and holes, bipolar junction transistor. It is a current control device. It consists of two PN junctions formed by sandwiching either N-type or P-type semiconducting between a pair of opposite types. The invention of the BJT is the basis for many advancements like integrated circuit. Usage of computers, electronic gadgets are possible to use nowadays. It can work as a conductor or insulator according to the input signal. Due to the property of the bipolar junction transistor can be used as switching at digital electronics, amplifier at analog electronics. This diagram shows the combination of the NPN transistor as well as the PN transistor. We already discussed in the previous slide, it has a three terminal. The terminals are called the emitter, base, and collector. These three terminals are common for both the configuration of PNP transistor or NPN transistor. The BJT appears as two back-to-back diode connected in series. If two diodes connected back to back, then no interaction between the diodes. Diodes works independently. Whereas bipolar junction transistor, there is interaction between the regions. Now, we are going to discuss about the two types of transistor and the symbol of transistor and what is emitter, what is base and collector. Here you can see that NPN transistor. In the previous slide, we seen that N N is a semiconducting material and P is the semiconducting material. Without this N layer, it's going to be a PN junction diode. Here we are adding another N layer to form the transistor. So this N layer going to act as the emitter terminal, the P layer going to act as the base region, and this N layer going to act as the collector. So this is the symbol of PN junction circuit. This is the symbol of NPN transistor. It has a three terminal. One is called collector, base, and emitter. which is outward projected. The arrow is outward projected. It indicates the emitter for NPN transistor. When we are talking about PNPN transistor, the arrow mark is inward projected. So the emitter region is inward projected. So it has a three terminal as like that of NPN transistor, namely we known as emitter, base, and collector. Here also, we are adding another P layer. In case of NPN transistor, we are adding N layer to the PN junction diode, where in case of PNP transistor, we are going to add another P layer to the PN junction diode. Now coming to the point of emitter. The emitter is a heavily doped one and base is lightly doped. The region width is narrower than the emitter and collector. And the collector is moderately doped region with this wider than other two. The function of emitter is to supply the electron named as emitter. Function of the collector region to collect the electrons from the emitter. So these are the different regions of operation. There will be a active mode operation, cutoff mode operation, and saturation mode of operation. You can see here NPN transistor taken into the consideration, and it has a two junction that is named as J1 and J2. In this active mode of operation, this NPN transistor, the P layer is connected to the positive of the terminal and N layer is connected to the negative of the terminal. So it going to act as the diode, as like that of diode, it is a forward bias of operation. Where in this another side, the P layer is connected to the negative of the power supply and the N layer is connected to the positive of the power supply. So it's going to act as the reverse bias mode of operation. So this is called active mode. Where another one, cutoff mode. In this cutoff mode of operation, the N layer is connected to the positive of the power supply and another N layer is connected to the again positive of the power supply. So both the combinations are same. So it's going to act as the cutoff mode. Where in case of saturation mode, the polarity will be reversed. That is N layer connected to the negative of the power supply and this N layer is connected to the negative of the power supply. It's going to act as the negative. It's going to act as the saturation mode of operation. Where in case of this active mode of operation, here we have a emitter, here we have base region that is going to provide the emitter base voltage. In this connection, here we have a base region, here we have a collector region. This is going to act as the collector base voltage. So BJT region of operation we seen in the previous slide, active, cutoff, saturation, and reverse active. Emitter based junction forward bias, collector based junction reverse bias, where in case of cutoff mode, reverse bias emitter based junction, collector based junction could be a reverse bias. Where in case of saturation, both should be a forward bias, where in case of reverse active mode of operation, emitter based junction should be a reverse bias and collector based junction should be a forward bias. Now we are going to discuss about the working of the PN junction, working of the BJT. So we know that it has a three layers. One is the N layer, another is a P layer, another is the N layer. That is the NPN transistor. Here you can see that this is going to be emitter region, this is going to be a base region, this is going to be a collector region. So this junction known as the emitter base junction, and this junction going to be act as the collector base junction. The E regions are heavily doped and wider, hence the number of free electrons, that is majority carriers, are large. The C regions are wider, but it's moderately doped, hence the number of electrons, free electrons, is not as much as the E region. Where B region is diffused in between of the wider emitter and collector region. The B region is quite thin compared to the outer emitter and the collector region, and also it's very lightly doped so that the number of holes is quite small. This is the connection of the NPN transistor. Here we can see that this N layer is connected to the negative of the power supply and the P layer going to be connected to the positive of the power supply. Emitter base junction becomes forward bias and the base collector junction becomes the reverse bias. In this condition, no current will flow through the device. Now, now here we are providing that base emitter voltage to this NPN diode. At the time, the electrons are starts to emit from the emitter layer to the collector layer. And there will be a chances of the recombination can be occurred in the P layer because the majority of the holes and the can be a majority of the holes in this P layer is going to be combined with the electrons emitting from the N layer. That is called recombination pair. So what are the electrons are emitted from this region, all collected by the collector region. There will be some leakage of electrons that is mentioned is a recombination pair. So that emitted current equal to be a base current plus collector current. Base emitter junction gets forward bias forward voltage individually. It can overcome the forward potential barrier and hence the majority carrier. The free electrons in the emitter region will cross the junction and come in the base region where they got very few number of holes to recombine because the layer will be very less so that electrons will start moving from the base region to collector region. But due to the electric field across the junction, the free electrons mitigating from the emitter region get kinetic energy. Base region is so thin and that the free electrons coming from the emitter do not get sufficient time to recombine and hence cross the reverse bias depletion region and ultimately come to the collector zone. The same principle as we are going to see in the PNPN transistor also.